Greeting, guys. So, welcome back. So, I'm too late to talk about MCP and A2A protocols, right? So I hope not, because they are like mind blowing and in the fast moving AI landscape, like every week feels like a new arms of rain. And then, like new models, new tools, new standards, like nobody wants to like left behind, right? And MCP and A2A are two of the most important standards shaping the future of AI agents. So, like a few months ago, like Anthropic released MCP, which is Model Context Protocol, and creating a standard way for like AI agents to talk to external tools and APIs. And recently, like OpenAI announced MCP integration too, and then showing it's like become a core building block for like multiple LLMs. And now Google has released A2A, which is Agent2Agent protocol, which lets the agents collaborate seamlessly with each other. So in short, we could say MCP is it's the standardized agent to tool communication, and the A2A it's standardized agent to agent communication. So they complement each other and not compete, right? And in this tutorial, we will be walking you through like what is MCP, and then what is A2A, and then we will see how they work together in real world AI application, and then also we will see how to like start using them in our own project. And finally we will be building MCP crypto price server as well. Okay, so let's dive in. So what is MCP? Like Model Context Protocol. It's a standardized way for AI agents like LLMs to talk to external APIs, database, and services. So imagine like if every tool, API, and database spoke a different language. So integrating them like all into your LLM would be a nightmare, right? So MCP fixes that by like offering a universal communication language between a client and server. When I talk about client, it's like an LLM app or IDE, and then server, which is like APIs, database, and more. So in short, like MCP, it's a USB for LLM plus tools. Okay, so you can plug in any tools that speaks MCP and it just works. So like why MCP exists, like LLMs need to like schedule the meetings like in Google Calendar, and then pull CRM data like from Salesforce, and then send emails from Gmails, and then we want to like query the database like PostgreSQL. Okay, so but every service has like different APIs, different field names, different authentication, and different error handling method. So writing a custom integration logic for every tool is like messy, right? It's repetitive and also doesn't scale. So MCP solves this by like providing a single predictable interface for all tools. So what are the components of MCP? So you do have like clients, okay? So clients is the app that hosts the LLM. So it connects to one or more MCP servers. And the second component is server, which is tool, API, database that offers the service via MCP. And then the third component is protocol, the rules like formats and communication methods that standardize the interaction. How MCP works, like the simply if we see like client connects to the server using MCP, and then client fetches a list of available tools or methods, and then LLM interpret user inputs and decides which tool to call, and then client sends the structured tool invocation via like MCP to server, and then like server executes the task like schedule meeting or fetches the weather, and finally the server responds with the result. What are the basic limitations of MCP? Like in terms of like security, it's hard to like guarantee the secure isolated execution across unknown servers. And regarding the scalability, like managing the auth token and rate limits across many MCP servers is tricky, right? And reliability, where some server implementations may not handle failures gracefully. And what are the key takeaways for this? Simply saying, your MCP is a USB standard for like connecting external devices to computers, right? So the second one is like agent to agent protocols, which is A2A protocol from Google. So A2A is a protocol for like direct communication between autonomous agents, while MCP handles agent to tool. Okay. But A2A handles agent to agent, right? So agents don't just call APIs now. They can collaborate with each other to solve complex workflow. So think of it like a team of agents working together. So each doing a part of the job, right? Why A2A exists? Like real world tasks often like need multiple specialized agents working together. For example, travel agent books a trip, right? Like hotel agent books accommodation, and cab agent which arranges the like transport. So instead of like one chained LLM doing everything, which is a bad idea, of course, and multiple smaller agents which can handle the the specialized task and then communicating using A2A. So what are the basic components of A2A? So one is like agent cards. So JSON documents that describes what an agent can do. The skills, constraints, and examples. And then second one is task. The actual job the agent assigned to each other. And the third component is messages. How agent exchange the information, results, and progress updates. So how A2A works? So basically, agent A, which is user-facing agent, which needs a task done. Okay. So the second step is like it discovers agent B via agent card, right, using the JSON. And then the third one is agent A sends a task to agent B using JSON RPC over HTTP or SSE. And then agent B updates the task update, which is pending, running, completed. Right? And then the result flow back naturally. So agents are like independent. The no centralized control needed. So key designs involved in A2A is like agent independence, which is agents are like fully autonomous, no shared state. And then the familiar tech stacks would be like HTTP, servers and events, which is SSC, and then JSON RPC. And then it's secure, like auth and authorization via like OpenID Connect. And then async support, which is long running task with like status update. And then flexible modalities, like it could handle like text, audio, video, charts, forms, and all these formats are supported. So what are the challenges with A2A? Basically, the agent discovery needs like good indexing. Otherwise, hard to like find right agents. And then conflict handling. While I'm talking about conflict handling, it's like two agents may give conflicting solutions. And then finally, latency. It's well known. Like multiple hands off, like can introduce slight delays. So still A2A like unlocks serious next gen capabilities like massive agent ecosystem that talks like humans, like delicate work today. So basically, the takeaway is A2A is agent to agent collaboration. It just uses a natural language task for intelligent delegations, and orchestrating the complex multi agent workflows are possible. The quick summary about MCP versus A2A is the first one is communication, which is agent to external API tools, and A2A is agent to agent, right? And the purpose of MCP is access tools and services, but the A2A is like multi agent collaboration. And architecture for MCP is structured rigid schema, which is RPC like, okay? And A2A is like more flexible and conversational. And then tech stack of MCP is like REST, HTTP, JSON. And in other hand, like A2A, it uses like JSON, RPC, HTTP, servers and events. And an analogy regarding the MCP is like USB port, okay, for example. And for A2A, you can think of like Slack workspace, okay. So where the analogy is like we are building agents for Slack, it can handle like modular teams and messaging to each other. So MCP gives like agents the arms and legs to act via tools, and A2A gives agents the brains and mouths to talk and collaborate with each other. So together, like they power the next generation of autonomous, modular, and intelligent AI system. The intelligent agentic system. So let's build a cryptocurrency price monitoring server using fast MCP. So basically, we will be doing like price checking, which will get the real-time cryptocurrency prices in USD, and then handles the multiple cryptocurrency symbols, and then we will be returning -1 if there is an error fetching the price. And second thing what we'll be doing is resource endpoint, which will provide the cryptocurrency prices through a crypto slash symbol endpoint, and which will be returns the formatted price information as a string. And then we will be including so you'll be getting the historical data, which will retrieve the price history for the last 30 days, which is configurable. You can change this according to your need. And then we'll be returning the data in CSV format with data and price. And finally, we will be doing price comparison, where we can compare the prices between two different cryptocurrencies and shows which cryptocurrency is higher and lower. And then we will be providing the formatted output current price. So to use this server, we'll call like get crypto price, which is the method to like get current price, and then we'll use like get crypto history, which is for to like get the historical data, and we'll be doing compare cryptos to compare two cryptocurrencies, and then we will access the prices via crypto slash resource endpoint. So the server runs automatically when the script is executed. Let's see how it works. Okay. So let's first install all the required packages which are needed to like run this. Pip install MCP CLI, which is needed for to run this, and we'll be installing the crypto compare as well for our use case. Okay, so we have installed the necessary packages. Now let's go back to the code. So let's see the code line by line. So in the first line, we are importing the first MCP class from MCP framework, so which is used to like create an MCP server. And then we will be importing the crypto compare library that provides access to like cryptocurrency price data. And then we are importing logging, which help us in the debugging purpose. And then we will be configuring the logging system to like show all debug level messages. And then we are creating a logger instance specific to this module. And then now we are creating a new MCP server instance with the name crypto price server. And here again logging. So here is our get crypto price method. So it will attempt to like fetch the price data for a given symbol in USD using crypto compare API. So by default we use like USD. What it will do is it will check if the price data exists and then contains the symbol, then it returns the price as a float. Like a -1 here, it will indicate the failure. And once we have done with this get cryptocurrency, let's go for like crypto resource. What it will do is it will expose the cryptocurrency price data as a resource and return a formatted string with a current price for a given symbol. BTC, which is Bitcoin, or ETH, which is Ethereum, or like BNB, which is Binance Coin, and so on. So basically, what it will depends a resource endpoint with a custom URI pattern for like accessing the crypto prices. And get crypto price here, what it will do is, as we saw earlier, it will like get the price and handles error cases with the descriptive messages. This is here. And then get crypto history. Okay, it just defines a tool for like getting the historical price data for a default 30 days. So it used like crypto compare to get the historical price for a given symbol, and then it just format the historical data as a CSV string with our date and price column here. I mean, the next method that we are using is like compare cryptos, where we will actually compare the crypto prices of two symbols. Okay, so it just defines a tool for like comparing prices of two cryptocurrencies, and what we will be doing is we will be getting the crypto price for comparison, and once it's done we will be comparing it here. Like, so if price 1 is like higher than price 2, we will be, I mean, returning the result as it's higher. Okay, as the price 1 is higher than the price 2. Okay, and then here we are like really starting our server. So it's a basic simple MCP server. So let's test it. Once it's done, let me execute the scripts. MCP dev crypto MCP. Okay, now let's relaunch the MCP inspector. Okay, Now we have to connect here, and then we have to go to tools, list the tools. So here we can see all the methods that we have defined here in the script. Okay, so basically we launched this MCP inspector using the command MCP dev and name of the server file. So this command will redirect us to the URL here, you see, so where the MCP inspector is serving. So using the user interface, we can now test various tools and like ensure everything is functioning as intended. So this server now exposes three services that we have created. One is get crypto prices and get crypto history, and then compare the cryptos. So let's try to like get the crypto price, okay, which will retrieve the current crypto price for the given symbol. So let's try for the first and most well-known cryptocurrency, which is BTC, which is Bitcoin. Okay, let's type BTC here and run the tool. So it just returned the price of the cryptocurrency in dollar. So let's test the get crypto history. So for that, let's test for again BTC for the last 30 days. So it just returns the crypto price of BTC in dollar. So once it's done, let's test the compare crypto method, where we can just try to compare two cryptocurrencies. We can test between BTC and the second largest cryptocurrency by market test now is like ETH, Ethereum. Let's run the tool. So it's saying like BTC is higher than ETH. So in terms of dollar, it just do have provided us with the value, I mean the price. So in this way, you can test and compare the cryptocurrencies using our simple MCP cryptocurrency server. So let's test with BNB as well, like a Binance coin. So again, BTC is higher than the BNB, right? Okay, we can test with other cryptocurrencies as well. So for the demo purpose, like I really want to give you some insight on how it works. Okay, so this compare crypto, which will compare the price of two cryptocurrencies and return the formatted message as we have defined earlier in the method. We can as well like do integrate this with so as well we can set up the MCP server for cloud desktop. So once we are like satisfied with our like MCP server, and we can integrate it into the cloud desktop by running the command like MCP install and the name of the server file, which is our Python file, and the name for the, in our case it's like cryptocurrency server. So when we relaunch the cloud desktop, like we can see the new icon which will pop up in the chat option. So this indicates that our MCP is configured, and we can now click on these icons to like check how many tools are available for the cloud desktop. So I will try to provide the link in the description below for to download the cloud desktop, test our cryptocurrency server on your side using a cloud desktop. You can test it by like asking the crypto desktop to like compare two cryptocurrencies prices. Okay, you can just prompt like could you please compare the price of Bitcoin and Binance. So after you enter the like prompt, it will request the permission to use the specified tool. And so if you want a detailed tutorial on this, please do let me know in the comment section. So basically, like MCP is a new concept that builds on like traditional ideas such as function calling and AI agents. So in the future, like we aim to like perfect these technologies to achieve seamless integration of external resources with our AI. So as a result, upon like your request, it will be able to like perform various tasks like ordering the groceries, sending emails, and creating Spotify playlist and sharing them with your friends. So that's it, guys. We are at the end of this tutorial. So if you have any questions, please do let me know in the comment section below. So I have provided the resources that we have used in this tutorial in the description below. And until then, this is Abunia. See you all in our next session. Bye bye.